Manufacturing process. Today I would like to discuss about welding and its types. This is Professor Venkatachalapathi, Institute of Aeronautical Engineering. I hope you have studied basic definition of welding and some of its types: arc welding, gas welding, resistance welding, electron beam welding, solid state welding. Today I would like to discuss about some of the fusion welding process, which is one of the most important for an mechanical engineering students to understand clearly. Now let us see fusion welding process. Before going to discuss about fusion welding process, as I said that the term welding can be defined as it is the process of joining two similar or dissimilar metals by adding filler without adding filler metal, by application of pressure without application of pressure. So this is a general definition of a welding process. Also we can call it as a fabrication process, and sometimes it may be called it as a secondary process. So in this session I am going to focus on fusion welding process. So this is the one of the most important welding process where in industrial sector are widely used to. So the major difference in fusion welding and pressure welding, only in the fusion welding process there will be electrode to be used, where in the case of pressure welding, so there is no filler metal can be used, only due to pressure, some type of classification in the pressure welding process. So coming to this fusion welding process, the term welding can be defined as it is the process of joining two similar metals or dissimilar metals by adding filler material and without adding filler metal, by application of heat and pressure without application of heat. And this is a common definition where we can speaking about the fusion welding process. Generally here that consumable electrode to be used and sometimes non-consumable electrode, depending upon the usage of this electrode, it can be classified into two types. One is the shielded metal arc welding and tungsten gas arc welding. So that is a TIG welding, MIG welding. So again it may be subdivided into, you can see where the consumable electrode to be used, there are again classified into three types, that is called shield metal arc welding, which have in the previous session I have explained about the how the shield metal arc welding can be processed, and gas metal arc welding and submerged arc welding. So the other two weldings also I am going to explain in detail in the next session. And today I am going to give the brief idea about the what is the major importance of this fusion welding process and how this can be applicable, proper advantages and some of the disadvantages, and where it can be applicable, that we'll discuss in detail. Okay, so as you know that any welding process there will be two rods. So for example, if you take there will be two plates or rods, and in this case how do you join? This is called, first one is a first plate and second plate. How do you join together? By adding filler metal, and with the help of some heating can be done, some sources of energy, that is called some electrical generator to be used to have some AC, DC and DCSP and DCRP, that we'll discuss in detail about this fusion welding process. And the majorly in this fusion welding process there are two basic type. One is the MIG welding, where you can use the consumable electrode, and TIG welding, gas tungsten inert gas arc welding. This is called GTAW, where you can use the non-consumable electrode. Okay, and similarly the another type is the high energy beam. So look at how the diagrams where I have shown here. It is a three-dimensional diagram where an operator, skilled workers, is performing the shielded metal arc welding. You can see how the shield will appear due to spark. So how they can able to use by using goggles and apron, etc., for the safety purpose. And this where you can see the welding torch, how it can be prepared, and how we can able to this filler. So that is called filler will be used for as an electrode, how it can able to use it. This diagram you can clearly understand the performing of fusion welding process, where you can use in a real life application. Okay, even this high energy beam, it's called some laser beam type of welding, and some energy beam. It is advanced type of welding process, where you can able to perform better and the advanced application types. Okay, now look at first one in the shielded metal arc welding. So in the previous session we had discussed about shielded metal arc welding, about how it is working and how the usage and how it can be applicable like that. Now in detail, a layman also can able to understand clearly how the working principle of shielded metal arc welding, and what are the important elements is required, what are the power sources, and what type of application. So you can see the shielded metal arc welding. So the diagrammatic, this is the figure 1, which shows that shielded metal arc welding, there will be a base metal. This is called base metal, and this is called a welded torch. We can call it as a torch, and how the flow of electrons will occur while performing this welding process. And there will be a weld metal, and above that shield, the slag, over that some slag and extra unwanted material will formed in the top of this weld metal. And here this form we can call it as a shield form. So inside some droplets, these are in this some droplets will form the weld bead can be occur in this two metals can be joined together, and there will be a core, that is electrode core wire will be introduced at the central of this, and also some flex coating also will be added to have a good strength and good quality of the welding can be occur. Okay, and basically in the shielded metal arc welding, most probably it can be used a consumable electrode. Yes or no? So here the consumable electrodes is widely used, and the electrode is a flex coated. So in order to, due to that flex only, strength and some extra slag will be removed with the help of the chipping hammer. And coming to this slag and oxygen of weld bead during the cooling. So whenever while performing this welding, and always it needs some cooling. So while that cooling, some slag will come out above the weld metal, that can be removed with the help of the chipping hammer. And sometimes some flex mainly used to focus to produce some protective shield around the weld pool. Okay, and the main purpose of this shielded metal arc welding is, it is a widely used general purpose welding. Wherever you go, small shops and small workshops also they can use this general purpose welding, is small rods and small window cabins, and any cables also can able to do this general purpose welding of shielded metal arc welding. And the thickness, obviously it can be varying from 1/8 inch to 3/4 inch. So the range of the thickness can be used in this shielded metal arc welding. It is approximately 1/8 to 3/3 inches size can be used. It is a portable type of mission where you can perform effectively in the shielded metal arc welding. And one interested thing, so that specification of the power requirement when doing this shielded metal arc welding is power P is equal to VI, that is how much voltage should be kept while performing this shielded metal arc welding. It is approximately 15 to 45 volts should be kept, and current is 50 to 300 amperes we are able to maintain. And obviously, so the power we can defend as with the multiplication, it is the product of current and voltage. Obviously, approximately it is 10 kilowatts. Okay, power can be utilized for this operation of the shielded metal arc welding. So this is a simple information regarding shielded metal arc welding. When the examination point of view, the student able to draw a line diagram, no need to draw a three-dimensional diagram also. You can able to draw one simple base metal and weld metal above the slab to be covered, and some gaseous shield can be performed like a flower types, and there will be a core wire and which will be covered with the flexed coating, so that some cooling also can be done to get a quality of the welding process. These were some highlights of the shielded metal arc welding. The student can able to write these points, should be able to remember and understand. You can able to project in the your examination point of view. Okay, so this is what about the shielded metal arc welding. Now let us see in the shielded metal arcing how the power, if you use the DC direct current that is generated to be used. So that is what here you can see. This is what the generator, DC generator to be used to performing. And here one another important thing is where you have to do, either it may be DCSP or either it may be DCRP. So the polarity also very important criteria for doing this shielded metal arc welding. So there are two different types. One is a straight polarity and reverse polarity. In the straight polarity, always the workpiece should be kept in a positive and electrode should be kept negative. So in the straight polarity, majority thin metals only can be used to weld. Okay, when you wanted to joining two thin metals, obviously you can use this straight polarity. And also this DC reverse polarity means just opposite to the straight polarity. That is, workpiece can be joined with the negative terminal and electrode will be kept in a positive. So wherever when you wanted to perform in a deeper weld penetration, obviously you can use the reverse polarity. So this is what about the DC direct current generators to be used to. Whereas AC either we are following 230 volts or 415 volts, it is a three-phase supply. That is very important. Even a skilled labor also should understand what type of requirement for the power is available and how to utilize this, either DC or AC. So AC means some fluctuation will be occur. In such case, some defects also may be occur. That's why some, especially in the shield metal arc welding, they can go for the this DC only, majority of the doing this welding process. And especially while using straight polarity, only shallow penetration will be occur. While using reverse polarity, deeper weld penetration should be made by this shielded metal arc welding. But where you can use the when you wanted to use the thick sections, obviously this DC cannot be performed. Okay, when you wanted to use for thick sections, obviously you can go for the AC current. So it gives some pulse arc. So whatever the some sine wave, some actually even the three-phase or in household we are using a single phase current, and all in industry sector and all we are going to use the three phase RYB, like that, where obviously while doing this some like sun wave, up and down sine wave will be occur due to sudden changes of this current also will be one most important parameter in this performing the shielded metal arc welding process. Okay, now let us see this another important type is the gas metal arc welding. So this is what about MIG welding, metal inert gas welding, where here you can able to use the consumable wire electrode. Okay, so consumable electrode, the electrode should be consumed. You can use the more number of electrodes to perform the this type of welding process. And here also you can see clearly understand with this small diagram in this figure, you can able to understand how it may be performed in a gas metal arc welding process. From this diagram you can clearly understand there will be a base metal and from the starting from left to right, and this is a solidified weld metal. So whenever we'll perform the welding, here it is solidified and it is going to be solidified, and this is a shield metal arc may be occur, and there will be a nozzle, and the electrode will be placed at the center of this electrode gun, and some shielded gas will come up through the flexus coating. And how do you feed the that wire to the spool? So this is a simple diagrammatic representation of gas metal arc welding process, and the torch will comprise of in a three-dimensional diagram of the this torch, how the gas metal arc welding torch can be proposed. In this case, inside there will be some nozzle, and the electrode will be kept inside. Whenever it consuming, the electrode is coming throughout continuously, and in this process, most probably metal inert gas welding, okay, MIG welding process. Obviously there is a consumable wire electrode to be used, and here shielding provided by the gas. You can use the gas to provide the shielded, and double productivity of SMAW. So where in the case of SMA only single productivity, here the double the productivity can be occurred. The productivity can be defined as it is the rate of how much output by input, how much output may obtain based on that input. So the double productivity can be achieved in this gas metal arc welding process. And finally, it is easily automated. So because of the some precautionary measures to be introduced and taken to be considered for a skilled person also, so that you should this is automatically used, means some extra setup also will be needed to avoid some accidents during the flames will fall on the ice and all. So that's why you should care to be taking the goggles and some shoes and some gloves and all to be used while performing any type of this welding process. And here also the DC reverse polarity can be used. So DC reverse polarity, this is what reverse polarity means. Always the workpiece will be kept negative and electrode will be kept to positive, so that we can able to have this hottest arc will be there, and where in the case of AC to be used, unstable arc can be used for this gas metal arc welding process. Here also some practical industry oriented applications also can perform in this gas metal arc welding process. So I hope you can got some clear about the metal inert gas arc welding and tungsten inert gas arc welding. So now another important type of welding is submerged arc welding. So when the three-dimensional figure, you can see clearly understand that how it will perform. Submerged arc welding. So it is like some underwater welding. We can use the submerged arc welding process also, where you can see the technical representation of this submerged arc welding. So in this case, the major construction of the submerged arc welding, there will be some workpiece, okay, and apart from that, how the two plates can be joined together, and here the flex feed from the hopper, and how the flex feed to be kept in the joint, and there will be electrode wire will be kept at the centrally, and there will be a jaw fixing of that electrode, the welding head jaws to be used to uniform size of the wire can be provided, and there will be earth led connection should be there in order to avoid the shocks and anything some supply side, okay. And also there will be a residual flex layer to be also used, and in the slag layer weld deposited in this all the pieces of that welding process, okay. So the main advantages and some major points related to submerged arc welding. So here also they can use the consumable wire electrode. In the submerged arc welding, we can go for the submerged arc welding process. And here also the shielding provided by flex granules. So in order to, you can see the material like some granule shape. So it is in some different polymeric shapes like square or hexagonal permanent type of shape of granules will be occur, so that the shielding can be avoided in this flex granules. And low UV radiation and flumes. Low UV radiation, ultraviolet radiation and flumes. In this case, submerged arc welding cannot show the UV rays and all, so that this welding can be performed in a better manner. And here the flex will be acted as a thermal insulator. This is what here this will be taken as an insulator, so that any shocks and some miscommunication of that power also can not be occur here. And this is also a submerged arc welding. It is an automated process. Only it can be limited to flat pieces. So wherever it is a square plate and rectangular plate of flat pieces, can you join some V joint and butt joint type of sections only can be done this submerged arc welding process. And here automatically very high speed. So compared to the previous welding process, it is a very high speed, and the quality also will occur maximum 10x quality. Okay, so the quality of the welding will be occur. Here no chipping also can be done automatically. The smooth layer will be occur. After cooling, it can be easily removed by the brush itself also. Okay, this is what about the some important points about the submerged arc welding. And the majorly this submerged arc welding will prefer for thick plates only. Automatically the thickness should be we can use more than some this is what thick plates, in the sense previously I have studied. You can see the thickness 1/8 inches to 3/4 inches of thickness can be used for this submerged arc welding process also. And here obviously the 440 voltage, so that is obviously the industry power. 3-phase supply should be required, and amperes current may 300 to 2000 amperes to be used for performing the submerged arc welding process. Some industrial applications also can be used for this submerged arc welding, wherever the thick type of flat plates can be easily done by this submerged arc welding. So this is what the student able to have this type of line diagram, so that to score maximum marks in the examination point of view. So this can be understand our three-dimensional diagram for understanding better in this. Even you can see that the granules and all, in order to avoid some flames and radiation, will be reduced and to be negligible to zero. Okay, so this is what about the submerged type of arc welding process. Okay, so now let us see another one more interesting type of welding process is TIG welding process. So most probably the student little bit difficulty in MIG welding and TIG welding. The only difference in MIG welding can be used for consumable electrode. TIG welding is a non-consumable electrode to be preferred. So the main important, sometimes in the competitive examinations also they can ask the TIG welding can be used dash type of electrode. Okay, there directly you can use the non-consumable electrode to be used for TIG welding process. So in this TIG welding also you can see clearly a simple line diagram of construction of the gas tungsten arc welding process. Okay, so from this diagram itself, it is a self-explanatory. So there will be a base metal. So this is called base metal, and here starting with the left to right. So here once it is welding is over, there is a solidified weld metal. Left side is unsolidified weld metal, and obviously there will be some torch will be there, can be controlled centrally. Tungsten electrode, non-consumable electrode, can be kept in the middle of the torch, and there will be gas nozzle, and shielding gas will be provided inside that nozzle, and the shield gas, like in this covered in performing this welding. So inside only the proper joining can be made with the available form. Okay. So and in this as known as TIG welding. TIG means tungsten inert gas, but obviously it can be used for the non-consumable electrode. And here sometimes with filler metal, without filler metal. So this is why gas tungsten arc welding, sometimes you can use filler metal, some type of application without filler metal also can able to join. And especially the shield gas, usually argon tungsten argon metal can be generally used for shielding purpose, and this especially for very thin sections. So it is used for thin sections such as aluminum, magnesium, and this titanium type of metals can be most widely used for gas tungsten arc welding process. And this is a little bit expensive process. Why? Because of this is a non-consumable electrode to be used, and setup of the process also will be somewhat complicated. And whatever the process of this welding, highest quality can be achieved in this gas tungsten arc welding process, because magnesium tungsten high quality of to be used metals, obviously we can perform a better quality of welding can be occur. And here another important, the power requirement is obviously 8 to 20 kilowatts to be used, and current is the DC is approximately 200 amperes to be used. For AC is 500 amperes. Okay, 500 is industrial power. Okay, household we are using 230 volts or 250 voltage, where the industry three phase 415 or 430, it is approximately 500 amperes to be used for this performing the gas tungsten inert gas welding process. Okay, so this is what about the gas tungsten arc welding process. This is a high quality process and most expensive process, where here sometimes filler metal can be used, sometimes without filler metal also can able to perform very thin sections, especially aluminum, magnesium, titanium type of materials can be easily fabricated using GTAW, that is gas tungsten arc welding process. Okay, so this is what about the gas tungsten arc welding. A student able to have these important points and some power requirements you can draw with the neat sketches in the examination point of view. Okay, now let us see how another important type of welding is a laser welding process. This is a little bit advanced type of welding process. Only thing is here we can able to do some laser beam to be produced by CO2 or YAZ laser. So this laser, the main importance of laser beam can be produced by a CO2 and YAZ laser. Especially in this case, you can see the three-dimensional diagram. This is what laser beam can be obtained when they're touching that workpiece to that electrode. Obviously, some laser beam should be placed and some spark will be occur. Okay, and sometimes this laser welding most widely used the applications is like medical devices, most probably medical and some jewelry section, some of the very thin sheet metals also can be performed in this laser welding process. And here can you see the how this laser welding can be performed in the left diagram. So in this how the laser rays formed in these two work pieces. So here this laser being produced by a CO2 or YAZ laser, and here high penetration and high speed process. This laser welding itself is a high penetration. Lot of penetration can be easily performed by the laser. Even for our human parts, some breakage of some leg and some elbows and all, they can be made by this laser treatment also. Even some skin also can be eliminated by laser treatment. So even in the welding process also, they can utilize some good quality with the high speed process within a fraction of a second you can able to perform. And here the heat also can be concentrated and very low distortion. The sound also very less, and distortion also very minimum in this laser welding process. And this laser can be shaped, focused, and pulsed on and off. Whenever you can on, then only the laser beam will be impulsed. Okay, so when it is off, after setting only you can able to on and off can be used. And this is also some of the important processes, automated process. The speed can be approximately 250 so speed FEM. Okay, so and here the workpieces also can be made 1 inch thickness of the metals can be easily done by this welding process, laser welding process. So the general typical laser welding applications are catheters and other some medical devices, small parts and some component where you can use in electronic components, also some fine wires and jewelry parts and some small sensors, some makes, some space research also application can use this laser welding process, and some thin sheet metals down to 0.001 inch thickness materials also can easily performed by this laser welding. This is the more advantages for the joining of very thin sections. Okay, so suppose if you use these type of sections in arc welding, MIG welding, it is very difficult to find. It will be very damaged. It cannot. It will be mixed with that high temperatures and things also. Okay, only laser beam can be in a fraction of second. It can be allow and to join together effectively. So this is what about the laser welding process. All the welding process, the principle is same. Any welding process is a process of joining to similar or dissimilar metals by adding filler. In this laser, there is no filler. Only here, some laser can be focused, like high beam will be focused on that material workpiece, and it's a concentrated heat can be used, and low distortion, no noise can be occurred while performing this welding. And it is an automated process. Obviously, this thickness only one up to 1 inch thickness can be performed in less than 1 inch also can be easily performed by this laser welding process. So this is what about the laser welding. These are the some major important points, and this 3-dimensional you can draw with can be in a 2D also. So 2D in the sense how the laser beam will be prepared with the gun, and there will be workpieces in the table, and how they can perform in this, and beams will be some light sources will be done here, and it can be attracted easily, and it can perform within a fraction of this automated process. Once you have to fix it within a little bit time, you can able to perform this laser welding process. Major application, jewelry application, some sensors, and medical applications widely used for this laser welding process. That is why all the students also they can understand about laser treatment, even for skin and bone fracture, and any internal things may be problem. This laser treatment one of the most widely used in the industry. This is what about the laser welding process. Okay, so this is what about the second part of welding process, and I hope this you can understand clearly what are the important related highlighted points, and how the diagrammatic representation of this type of welding. So what are the advantages and limitations, and how the major applications for the respective welding process. Okay, thank you for this.
Like, share and subscribe. Hit the bell icon for more updates.